Okay, the first thing is when we're solving equations, we're trying to isolate our variable, and the way we do that is by undoing whatever is happening to the variable. If I have x plus 2 equals, I want to undo plus 2, so I do the inverse. And what's the inverse of adding? Subtracting. If I have 2 times x, I want to undo the multiplication of 2, so how do I do that? I divide. Addition and subtraction undo each other. Multiplication and division undo each other. If you have the square root of x, and you want to undo that, what do? You square it, okay? A radical and then raising it to that power. For instance, the cubed root of x, how do you undo the cubed root of x? You cube it. The fifth root of x, how do you undo that? Raise it to the fifth power, okay? Very simple. In solving regular equations, like I said, you don't have to write this yet. I'll tell you when to start writing. We are ultimately trying to isolate x, or the variable, whatever it is. Well, it's this. We're still trying to do the same thing when we're dealing with radicals. Now start. Here are the 3 things, or actually it's 4 things that we need to take into consideration and look at when we're solving an equation that involves radical expressions. The first thing we're going to do is we're going to isolate the radical on one side of the equation. Anything that's under that hat, it's a grouping symbol. We're going to get everything else on the other side. After we've isolated the radical, we're going to undo it. Now, if it's a square root, you're going to undo it by squaring. If it's a cubed root, you'll undo it by cubing. But remember, in equations, anything you do on one side, you got to do it to the other side. Okay? So you're going to isolate your radical. Then you're going to undo the radical by doing the same thing on both sides of the equation. Now, this is really needs to be in conjunction with number 2. When you isolate that radical, you need to be where? Remember that an even root cannot equal a negative number. You cannot get a real solution that way. So when you get your radical by itself, if you have the square root of x equals negative 10, from there you should automatically know what? There's no real solution. So you don't need to go any further. For now, until we learn about I, which will be next week. All right, so for now, we'll go ahead and we'll continue to solve. So be conscious about if there is a solution or not, and then you're just going to solve the equation, because once you get rid of the radical, it's just a simple equation. And then finally, always check your answer. That's not just to check your math. Sometimes it may not work out. Sometimes you may get a solution, and when you plug it back in, it's not actually true, which means that there's no real solution. Okay, so always check your answer. Now, here's the first problem we're going to try. The square root of x plus 1. And then out of the radical, we have plus 2 equals 4. Now, what was the first step I said to do? Isolate the radical. What's not under the radical? Plus 2. How do you undo plus 2? You're going to subtract 2 from both sides. And when you do, you get the square root of x plus 1 equals 2. Can a square root be positive? Yes, it can. So we're going to keep going. All right, now that I've isolated the radical, the next step was undo the radical. It's the square root. How do you undo a square root? You square. But what you do to one side, you also have to do to the other, right? What do you end up with on the left?
X plus 1.
X plus 1. If the whole thing's under a square root and I square it, these simply cancel each other. And so all I have is x plus 1. What was your question, Kirsten?
Why did you square it?
Because I'm trying to undo the square root. I'm trying to get rid of the radical. And that's the opposite. And then 2 squared is 4.
How would it be a -2?
Because when I subtract 2 from both sides, 4 minus 2 is positive. Okay? All right, so what's x? X is 3. Well, what was the last thing I had you write down? Always check. Go back to your original. Assume that's a 3. What's 3 plus 1? What's the square root of 4? What's 2 plus 2? 4. It checks out. So I do have a solution. My solution is x equals 3. Okay? Isolate your radical. Undo it. Solve. And check. Isolate your radical. Make sure you can solve it. Can you solve it, John? Why not? Because the square root can't be negative. Very good. If I'm going to isolate this radical, I've got to get rid of plus 1. That means I've got to subtract 1 from both sides. So now I have that the square root of something is equal to a -1. Can the square root of anything be negative? No. Okay, so for now, as long as we haven't learned about imaginary numbers yet, from here there's no solution, no real solution. Yes?
But like once you do the little square thing, doesn't it?
After you square it, it works, okay? But before you square it, it doesn't. So as long as we get to a point where it doesn't work, then we have to stop, all right? There are 2 steps involved in isolating this radical. 2 times the square root of z minus 6. Then you have minus 6 equals 0. James, what should you do first? Oh, no. This is basically like an equation like this. What would you do first in this equation? Add 6, okay? You undo addition and subtraction first before you undo multiplication. So your first step is to add 6 to both sides. Then what do? Then you divide both sides by 2. And so you get the square root of z minus 6 is equal to 3. Can that be solved? Can you find a square root and get positive 3? Yes. Okay, so what's next? Square both sides. I'm trying to get rid of square roots, so I'm going to square both sides. Tyler, what do you have on here? What's left over here on the left? Equals 9. So what's z? 15. But what do we need to make sure of? We got to check it.